Hello, this is Dr. Rodi. This video will show how to use the TI84 calculator to compute a linear regression equation. I will use this example here. Below are data relating EQ, a measure of emotional intelligence, of an insurance company's sales force to sales as measured by the number of policies sold in the last month. Determine the linear regression equation to predict sales based on EQ, and we're going to round it to 2 decimal places. So here's the data list. And what we want to do first is determine which variable is the x variable and which variable is the y variable. Another word for the x variable is the independent variable or the explanatory variable. Another word for the y variable would be the dependent variable or the response variable. Now in this case, we're predicting sales based on the EQ. So the sales are responding to EQ. EQ is explaining the sales in a sense. So what we're predicting is the y variable, and the other variable that it's based on will be the x variable. So in this case, EQ will be x and sales will be y. Now in the graphing calculator, the default x list is list 1. The default y list is list 2. So that's the list I'm going to use. And if I hit stat, and then go to the edit command, you will see I've typed this data into these lists. And notice that the data is paired up. You don't want to sort this data. You want it paired up the way it is in the actual data set. It's very important that when you type in your data, you go through and audit it and make sure that you have all the numbers in correctly. Okay, now to the calculation. Again, I'm going to use the stat command. And then I'm going to arrow to the right and hit calculate. Then I'm going to go down, and if I notice, you can see linreg AX plus B. But AX plus B is not usually the form that you will find in most statistics books. So if you continue down, even though that's the form you're familiar with from some algebra classes, if you arrow down to number 8, it's linreg again, but this is the form A plus BX, which is the more common form that you see in introductory statistics textbooks. So we're going to choose this choice, number 8. The calculations will be the same, just the roles of A and B are reversed. So I can either hit the number 8 or hit the enter key after highlighting 8. And now I get a menu of choices. I can choose where my X list is, where my Y list, and so on. Well, I put my X and Y in list 1 and list 2, so since that's the default, these are already there, and that made my life easy. If I had chosen different lists for these variables, I would just do the second and then number button corresponding to the list to identify the proper list. For this particular situation, we don't need to worry about the frequency list, and I'm not going to bother with storing the regression equation into one of the variables, but you could. By hitting vars and going to yvars and function, you can pick one of the y variables to store the regression equation, but we're just going to look at it on the screen as it comes out. So I'm going to arrow down to calculate. Now this menu here is in the TI84 with the stat wizard function. If you have an older TI84 or a TI83 calculator, it will be done a little bit differently, and I will do that at the end of the video to show you. So I'm going to hit calculate. And what comes out is my output. And what I have here is my form of the equation, the values for the two parameters A and B. And then down here, I will talk about these values in a minute. So if you notice, the equation is of the form A plus BX. A is this particular number here. So if I substitute that in for A and substitute this number in for B, the slope of the line, then I'll get my regression equation. So let's look over here. A rounded to 2 decimal places will be 13.60 negative, plus B, which is 0.32 rounded to 2 decimal places. So my regression equation looks like this. If you write it with symbols, then it's a good idea to define what your symbols are. Or you could write it in words. A lot of computer output will do it in this format. So the variable names are used as the variables rather than Y and X. And this is how you would compute the values of the parameters of a regression equation and then write the regression equation given the list of data for a particular situation. Now let's talk about R and R squared. R is the correlation, which is a measure of the strength and direction of the linear association between X and Y. So R will vary between 0 and 1 in absolute value. So actually it goes from -1 to +1. The closer an absolute value R is to 1, the stronger the linear relationship. So in this case, it's 0.9, which means I have a very strong linear relationship, which means a line is a good model for this data. R squared is the coefficient of determination. The coefficient of determination measures the variability or the variation in y due to its linear relationship with x. And it is literally r squared. And sometimes we express this as a percent as well. Now I'm going to show how to do this if you have a TI83 or an older model TI84. I will show you how it looks in that situation. Okay, you want to do the same thing, type your data in, but when you go to Stat Calc and you go to number 8, notice you don't get the menu anymore. You just get this choice right here. And what it's doing is it's asking you, where is the data? Where's the X data? Where's the Y data? Well, the default is it's X is in list 1, Y is in list 2. So actually we can just hit enter because that's where we put our data. And notice we get the same results.